So in this video, we'll be taking a look at how we put a robot into motion. For the purposes of demonstration, I'm using the generic Lynx robot here that can be found in the toolbox. And what you're going to notice that separates your Lynx from mine is that I've removed all the constraints as well as the actuators from this particular model to give me a lifeless robot. And what we'll see by that is when I hit play in the simulator, this robot just falls apart. And that's because I haven't specified any constraints. In the eyes of robotBuilder, the wheels are not physically connected in any way, shape, or form to the chassis. So as part of my demonstration, we're going to take a look at how we go about assigning constraints, how do we add actuators that will put this robot into motion, and then finally we'll take a look at how we go about mapping device controls so that we can actually control and drive this robot around within robotBuilder. So I'm just going to reset my model and I'm going to get this toolbox out of the way. And we take a look here at the hierarchy view. I have here basically a work surface, which is my plane. I have the Lynx and its sub-assemblies include a deck, a chassis, and 4 wheels. If I right click on the chassis and click on add, I get this sub-menu that comes up, and I'm going to add some roles to this robot. Now, simply put, roles are what makes components active. And a robot can have many roles. As you can see here, roles are roughly divided into 4 broad categories: actuators, devices, robots, and sensors. We're going to start by taking a look at actuators. Simply put, actuators are devices that cause motion. So an actuator will usually have a body that it acts on. For example, this motor might act on the wheels of the robot. In this particular instance, I'm going to assign 4 motors. I'm going to assign a motor to each of the 4 wheels, and that will just allow me to have a greater level of control when it comes time to assign keys to the device menu. So I'm going to add 4 motors, but I could have just as easily have added a thruster. I have a track drive, a gripper. The theme here with actuators is that they put an object into motion. The other roles within this menu are devices. So for example, I could have added this camera. Robots, which are sort of a generic role that is used to coordinate communication between the electronic components that are hosted within the robot. I have a variety of sensors that will allow the robot to make sense of its external environment. So for example, I could add a GPS, a camera, a bump sensor, or a generic sonar to this robot if I so chose. For the time being, I'm just going to use the 4 motors. I'm going to hit OK. You'll notice now, when I undock this properties window, that I have 4 new buttons that have shown up, and they all say actuator motor. That's not a particularly descriptive name, and so I'm going to specify something that's a little more useful. You'll find that as you work with your model and it grows in complexity, that you'll want to use very descriptive names because it will help you make sense of what you're working on down the road. So let's take this actuator, and I'm going to retitle it, let's call this front left drive, and I'm going to abbreviate it as FLD. If we take a look down here, we have a couple of different variables we can manipulate. So we have the axis that this actuator is working on, and the default is for it to be set at 100. Then I have things like a D gain, I gain, P gain. These all relate to the variables one might manipulate on a PID controller. That's a little bit out of the scope of this particular video, but know that they're there if you want to play with them. Most importantly, we want to set a drive body. So my very first wheel drive, I'm going to assign to the wheel front left. And I'll close this window. You'll note now that my actuator has the descriptive name FLD and motor. I'm going to go about assigning wheel drives to the remaining 3 wheels. So I'm going to call this front right drive. And I'll assign the wheel to the wheel front right. I also have here a rear left drive, and I will assign it to the wheel rear left. And lastly, I will assign a rear right drive, and I will assign it to the wheel rear right. So we've assigned an actuator to each of the 4 wheels. Now we have to specify the constraints. We need to physically connect these wheels to the body of our robot. To do that, we're going to open up a window that we previously haven't seen. That's called the constraint view. I'm just going to undock this for a second so we can take a peek. A lot of our constraints as they develop will show up in this window, and a lot of our work that we will be doing will happen here. So if you do not have the constraint view window open, you can find it by clicking on the view menu and constraint view. If you click on that, this window will appear. I'm going to put this over to the side so I have some space to work with. And I'm going to add my 4 wheel constraints. So to do that, click on environment, add constraint, and here we get a whole pile of presets that we can use. So for example, I could use a ball socket constraint, a fixed constraint, piston constraint, spring constraint. I'm going to use the custom constraint just because it gives me a couple more variables to work with. To recommend, if I were starting out though, I would probably be inclined to use one of the presets because they're a little more user friendly. If you need more information on the constraints, you can always find it in the documentation by clicking Help, Documentation. And if I click on the sitemap here, I can find constraints under the physics heading. And in very specific language, each of these variables is detailed as to what it does. So you may want to spend some time reading this because it will make you a little more productive down the road. I can also find information on all of the roles that we've just discussed here in the documentation as well. So please be aware of that. You may find that that's useful to come back to at a later date. So we will add, for the purposes of this video, 4 custom constraints. So add 1, custom constraint 2, 3, and 4. Now you'll notice in my constraint view that I get these 4 generic constraints. And like the rules before it, I'm going to assign a very specific name to each of these. So I'll call this first constraint front left constraint. If I expand this window, I'll briefly touch on some of the things that are happening here. The anchor specifies the position on the main body relative to the, the anchor specifies the position of the secondary body relative to the main body where things are connected. So in this particular case, I'm going to want to have my wheels connected at the origin of the robot's chassis. So I will leave it at 0, 0, 0. I also have the axis that the constraint is held upon. The default is for it to be at 0, 0, 1. I prefer to set it at 1, 0, 0. Again, it's an issue of personal taste and what you're trying to accomplish. The brake force and brake torque specify the upper limits on force, that if these 2 limits are exceeded, whether the robot is dropped or whether the torque exceeds this value, the constraint will be broken. So the default is usually pretty good to leave with, and I will keep the default as is. This is really the most important part. This is where we specify the 2 connected bodies. So in this particular case, for the front left constraint, I'm going to make my main body the wheel front left. The secondary body is going to be the body of the robot. And here we get a couple more variables that we can play with. What I want to do is I want to lock this wheel down so that it really doesn't move. It can only be twisted. And so, for example, swing limit 1, that specifies how the 2 bodies will rotate to each other relative to the y-axis. I want that locked. I don't want this wheel to rotate along its y-axis. I just want it to be twisted along the x. Swing limit 2 is how these 2 objects will rotate relative to each other along the z-axis. Again, I will want to have that locked. The twist drive, I want to keep free because I want my wheels to be able to rotate freely. And then the X, Y, and Z drives here specify how these 2 objects will move relative to each other along each of the axes. So I'm going to lock those as well. I really just want this wheel to rotate, and otherwise I want it to be really constrained to the body of my robot, because if I don't do that, I'll get some really weird behaviors that happen when it comes time to assigning the drive controls. So I will do that now for each of the 4 constraints. You'll note now here in my constraint view, it says front left constraint, and it shows the 2 connected bodies. I'm going to go into each of these other constraints, and I'm going to assign a name, and I will spell out the relationship between each of the wheels and the main body. So let's call this front right constraint. And again, I'm going to change the connecting axis, and I'm going to lock down all of my dimensions except for my twist drive, which is how objects are rotated along the x-axis. I will call this constraint rear left constraint. And I'll change the axes. You'll want to be very careful assigning each of these properties, because later on, if something unusual does happen to your model, you're going to have a pretty awful time trying to hunt down the source of your frustration. So I'm moving maybe a little bit slower than I would like, but hopefully I'll have the satisfaction of getting this right the first time around. Okay, so I'm going to get this properties window out of the way, and I'll move this constraints window down here. And let's see what happens now when I hit play on the simulator. So something weird has happened, right? Look at this, robot was moving on its own, it lost one of its wheels, so right away that's a cue that there's something unusual with how I've set this up. I'm going to reset my robot. It looks to me like there's something unusual happening there with my motors, so I'm just going to go into my hierarchy view, and I'm going to go to the chassis, and I will open up the properties window for the chassis, and let's just undock this. And this is probably the source of my pain, is that the proportional gain is a little too extreme for what I need. So what's happening is the motors are running, and they're causing the body of this robot to jump all over the place. Let's turn this down a little bit. So I'll turn it down to 0.01, and I will do that for the other 3 motors. So let's change this to 0.01 for the P gain, 0.01, and 0.01. And now when I hit play, the robot is stationary, but I lost a wheel. So let's take a look at our constraints and see what's happening here. So this custom constraint, I should give it a descriptive name, which I didn't do. I will call this rear right constraint. And I see that my wheel rear right and the links are connected. That's good. Front left constraint is properly titled, but look, I haven't assigned a relationship between the main body and the wheel. That's why my wheel fell off. So for the front right constraint, I will make the wheel front right, the main body, and I will connect it to my links. And the rest of these should be okay. So let's hit play now. Perfect. Our robot stays together, so we're now 2/3 of the way there. The last thing that remains is we're going to assign keys on our keyboard to the model so that we can actually drive this robot around and test it. To do that, click on the device menu up here and come down to device controls. And here what we see is the fruits of our labor for assigning meaningful names. This would have been a really awful process if I had kept each of my wheel drives named actuator motor. But here I have a front left drive, a front right drive, a rear rear left drive and a rear right drive, as abbreviated by the three letters. So I'm going to add a front left drive. I'm going to add a front right drive. I'm going to add a rear left drive, and I'm also going to add a rear right drive. Now, as we go through this process, it might be a little tedious setting each of these individual controls. So what I'm going to do is I'm actually going to group them, and I'm going to assign a block level property to each of them. So I'm going to make my my drive letter on my keyboard W. Note that when I do that, all of the devices use W as an input. And we're going to say that when W is pressed down, set the speed to 100. Speed is 100. Let's now specify a way of stopping this robot. So I'm going to assign again each of these devices. I'm going to group them. I'm going to use the W key again, but this time I'm going to say when W is up, set the speed to 0. So when W is down, drive the robot in a straight line. When it's up, set the speed to 0. I'm going to save, and I'm just going to anchor this so we can see what's happening. And I'm going to hit play, and now when I press W, my robot drives. When the W key has been lifted, it stops. So drive, stop. Perfect. Now let's stop the simulator. Let's reset our robot, and let's assign some other controls so that we can turn this robot. So again, device controls. I'm going to add a function that will allow this robot to turn. So I'm going to add each of these. I'm going to group them. And I'm going to assign my turn key as the letter A. And we're going to say that when A is pressed, it will turn the vehicle to the left. So I will set the front left drive a value of 100. The front right drive will be minus 100 because it's going to help compensate and assist the left motor in turning. The rear left drive will also be 100, and the rear right drive will be minus 100. And let's save that and see what happens. So now when I hit W, the robot moves forward, and when I hit A, my robot turns left. So that pretty much concludes this session. Keep that in mind, and be mindful of the idea that it will take a lot of practice to get good at using these controls. And that if there's some kind of unusual behavior happening with your robot, more often than not, it's because you are missing a constraint, or a constraint that you've specified is incorrect. So be very careful when assigning constraints, and be mindful that there's always additional information in the help documentation, which will go a long way towards making your life a little less stressful.